Hi students, today we are going to discuss the concepts of the pole and polar. So what is the pole and what is the polar of a point with respect to the circle? So the definition. First we see the concept. Here this is the circle. Now we draw the sequence from a point P to the circle. So they meet at capital A and capital B, and another secant meet at capital C and capital D. Draw the tangents at capital A and capital B to the circle, and also draw the tangents at capital C and capital D. These tangents are intersected at the 2 points. Now join the line these point of intersection of the tangents. This line is known as the polar of the point P with respect to the circle. So see this diagram, and now your definition is let S is equal to 0 be the circle. Draw the secant from an external point P to the circle. It meets the circle at capital A and capital B. Then the locus of the point of intersection of the tangents at capital A and capital B is called the polar of P. The locus forms a straight line. The locus forms a straight line, which is the polar of P with respect to the circle, and the point P is called the pole of the polar. So here the polar is the line and P is the pole of the circle. So the line is polar of P with respect to the circle, and the point is the pole of the line with respect to the circle. So this is the concept of the pole and polar. In that there are some cases. First case is if the point P, which is outside of the circle, then the polar forms polar forms inside of the circle. See this diagram again. So this is the circle. Draw the secants from external point P to the circle, and they meet at capital A and capital B. Draw the tangents at capital A and capital B, and another secant meet at capital C and capital D, and also write the tangents at C and D. So these tangents are intersected. Now the intersecting points of these tangents join the line. So that is the locus of the point of intersection of the tangents drawn at A and B and C and D. This line is the polar of P with respect to the circle. Next case, see the next case. If the point P, which is inside of the circle, then the polar forms outside of the circle. See this circle. If the point is inside of the circle, draw the secant from P. Draw the secants from P to the circles. So we have number of secants drawn through the point P. So now these secants meet at capital A and capital B. Now we are write the tangents at capital A and capital B and capital C and capital D. Now we have to write the tangents where the secants meet the circle. These tangents are intersected. That intersecting points line joining is here the polar. So here point is inside of the circle, then the polar forms outside of the circle. In this case, the polar outside, the point is inside. So the line is the polar of P with respect to the circle, and point P is called the pole of the line of the polar with respect to the circle. Next case, if the point P which is lies on the circle, then the polar is coincides with the tangent at the point of contact. That is, the tangent at point P coincides with the polar. See this diagram. So if the point P lies on the circle, what is the definition of the polar? So from that point we are writing the secants. So here only one secant, that is nothing but the tangent at the point. That secant coincides with the tangent at P. That is the polar of P with respect to the circle. Next case 4. If P is the center of the circle, that is P is we are taken the center of the circle, then the polar does not exist, since the tangents are parallel to each other. So this is the circle. What is the concept of the pole and polar? So if we take a point P, now we are in the above case, P is inside of the circle. Here the P point is at the center. We are taken the point P is at the center. That is, P is equal to C. Now we are write the secants from the point P. That is the concept of the polar. So where the secant meets the circle, draw the tangents. So here these tangents are parallel to each other. These tangents are parallel to each other. So the pole are not formed here. Next, the theorem. The equation of the polar of the point P of x1, y1 with respect to the circle S is equal to 0 is S1 is equal to 0. Now we are writing the equation of the point x1, y1 with respect to the S is equal to 0 is S1 is equal to 0. So that is the theorem. Now proof is, let AB is any chord drawn through the point P of x1, y1 at the tangents at capital A and capital B. See the diagram. So this is the circle. Now draw the secant through capital P. They meet at capital A and capital B. Capital A and capital B. Now draw the tangents at capital A and capital B. They meet at capital R. Now this chord AB is the chord of the circle. Now this chord is the polar of R. Or we are taken R point is alpha comma beta. Here AB chord is the polar of R. Now we are writing the chord equation. So therefore AB is the chord of contact of R of alpha comma beta. Here AB is the chord of contact of R with respect to the circle. Now we are writing the equation of the chord. The equation of the chord AB is x alpha plus y beta plus g into x plus alpha plus f into y plus beta plus c is equal to 0. This is the chord of AB. So this chord passing through the x1, y1. So this chord passing through P of x1, y1. Now this point is substituted in the chord equation AB. Now in the place of x is x1 and y is y1, we are getting the equation x1 alpha plus y1 beta plus g into x plus x1 plus alpha plus f into y1 plus beta plus c is equal to 0. So this is the locus of R. So now we are writing the locus of R is in the place of alpha is x1 and beta is y1. Then we are getting the locus of R. R locus is x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. So this locus of R is the equation of polar, that is S1 is equal to 0. Now this is the final conclusion. The equation of the polar of the point P of x1 y1 with respect to s is equal to 0 is s1 is equal to 0. That is the equation of the polar of x1 y1.